Exponential and reciprocal functions. Consider f of x equals to 3 to the power of x and g of x equals to 3 over x. Explain similarities and differences between the graphs of the above functions. So we are given two functions. One is exponential function 3 to the power of x. The other one is the reciprocal function 3 over x. Now we need to figure out what are the similarities between these graphs and what are the differences. Well, you know a lot about functions by now, so you can pause the video, write down your answer, and then check with my suggestions, right? Okay, so let's first graph these functions, and then it'll be easier for us to explain, right? So this is our coordinate axis. When we say 3 to the power of x, which is f of x, so it'd be a graph which would be kind of increasing like this, right? So that is 3 to the power of x. We can say f of x, which is equals to 3 to the power of x. Now let's sketch 3 over x, right? So 3 over x, when x is equal to 0, then we have a vertical asymptote, right? So for 3 over x, let me draw a vertical asymptote first. That is a y-axis, or x equals to 0 is a vertical asymptote. Now, if x is 1, then the value of the function is 3. So if x is 1, let us say this is 1 for us. In that case, the value of the function will be 3. Now, I put a point here on 3 to the power of x because if x is 1, 3 to the power of 1 is also 3. So that point is common, right? So that's a common point for us. Now, if x is minus 1, in that case it will be minus 3, right? So if it's minus 1, so it is going to be minus 3, right? So as you can see, the graph of 3 over x should be kind of like this. I mean, I really stretch it a lot on the other side. So let me now draw like this, kind of like this, right? So that is 3 over x, and here it will be kind of like this. So this is the graph g of x equals to 3 over x, which is in red, right? Now what similarities do you see between the two? Let's list. So what do you think are the similarities? Now as far as the similarities go, we can say, one, we found that they do have a common point, that is 1 and 3. So we can say 1 and 3 is common point, right? That is a similarity, correct? Now what else? One similarity which we can see is that x-axis is actually a horizontal asymptote for both the graphs. So it is approaching, correct? So we have x-axis, or y equals to 0 is horizontal asymptote. Well, that is also a similarity, right? As x approaches minus infinity, it's a horizontal asymptote for the exponential function. As far as the reciprocal function is concerned, it approaches x-axis as x approaches plus or minus infinity. Okay, so these are the two similarities. Okay, so now let's talk about the differences between the two graphs. So as far as differences goes, what can you say? One, we can say, well, the domain of f of x is all real numbers. So one is that domain is a difference, right? So domain is restricted. As x is not equal to 0 for g of x, correct? But for f of x, there is no restriction, right? For f of x, x belongs to real numbers. So one is the difference in the domain itself. And second, just because the domain, why the restriction? We have a vertical asymptote. So we have a vertical asymptote for reciprocal function g of x, right? But not for f of x, correct? Then as you can see, if you see within the domain, then the reciprocal function is decreasing in its domain. Do you see that? But the exponential function is increasing. So we have f of x is always increasing, correct? But g of x is decreasing in its domain. So these are the differences which we can highlight in this particular case. It's a very important question, and that's why I kind of wrote them down here. So I'd like you to make a note and find some more differences or similarities between these, but these are very major differences and similarities for these two graphs, and it's a very important question from test point of view also. So have a good look at it, think about it, and figure out some more differences and similarities between these two functions. They will surely help you. Have a good look. Thank you and all the best.